Alrighty, for this one, yeah, my camera's a little bit weird right now, and I'm not going to worry about it because I laid the computer down. So you're going to look up my nose if you want to, but I'm here. Um, all right, so what we're talking about in this one is dilution. And in a dilution, what we're doing is we're going to use a solution to make a different solution. Okay, so you're essentially, I'm not ready. There it is. Use a solution to make a new solution. Okay. Typically, what you're doing is you're taking a higher concentrated solution and using it to make a lower concentrated solution. Okay. Um, right. So if you look at it this way, if like this is doing this, shit. Come back. Again, why is my computer being stupid? Okay. Right. If you look at it from this perspective, right, we have a high concentrated solution. So this is a concentrated solution. And we're adding solvent to it here. This is probably water. And we're making a dilute solution. Okay. Now, the nice thing about this is that when we do this process, the number of moles is going to be the same. Okay. But the volume is increasing. Okay. And remember, since molarity equals moles per liter, if we increase the, oops, not increasing the moles, if we keep the moles the same and increase the volume, I'm too tired, increase the volume, then our molarity is going to go down. Okay. Um, there are, and our big goal here is we want to think about how we're going to calculate these things, right? How do we know what the final diluted volume is, or how do we prepare a particular solution? Okay. So let's take a stab at this. All right. There's two big ways to do this. I'm going to show you both ways to do it, and you can decide which way feels good to you. The first route, this 1A, I'm going to use dimensional analysis. Remember, dimensional analysis will always get you where you're going. Okay. So the question is, we want to know what volume of stock solution um, that has a concentration of 11.65 molar is needed to make a 3.5 liter solution that has a concentration of 4.25 molar. Okay. Every time we're looking at a dilution problem, we want to find that we're going to be given a volume and a concentration that go together. So here's the volume we're given, and this concentration is this. The magic word here is of. So this volume of this concentration ties these two values together. Okay. And then this one is left on its own. So what we're doing is this is our known and this is our unknown. Okay. Um, and when we're working through a problem like this, we're going to need, remember, we're looking for, oh wait, what volume of stock solution? So we need to figure out the moles that we need for the dilute solution, and we're going to figure out the volume of the stock solution that does that. Your known is going to lead you to moles because you know both the concentration and the volume. So that's our start. Okay. And we're starting with liters because that only has one unit with it. Remember, our 4.25 is 4.25 moles for 1 liter, and the liters go on the bottom, so it cancels out. Now, what we're going to do is say, okay, this is how many moles we need to make the dilute solution. Our stock solution has this many moles in a liter. So that's 11.65 moles in 1 liter. All right. That's all we're going to do. Right. This will give us, so what we've done, if we look at it, is we've said, okay, this calculation will give us moles needed. Okay. The answer from here and this will tell us the volume of stock that has that many moles in it. Okay. And when we multiply all this out and divide things around, what we'll get is 1.27628 liters of stock solution, which for three significant figures is 1.28. Okay. That's one way to do it. This way will always get it done. Just remember, you got to figure out moles and you got to figure out how many liters has that many moles in it. Um, you could do this as two separate things. I like to string them together, but there it is. Um, if we want to come at it a different way, we can use what's called the dilution equation. That's this. Okay. If you want to use the dilution equation, you can. Okay. Um, I'm not going to give you the dilution equation, so you just have to know it. Okay. Um, but I'm going to give you a caveat here. This equation is the dilution equation, and it only works for dilution problems. If you use this equation on a problem that is not a dilution, you'll get 0 points for that problem, even if you somehow magically get the correct answer. Okay. So if you never want to use the dilution equation, that is absolutely fine. If you want to use it, that's good, but use it for just dilutions. Okay. The process is going to be the same thing. We want to find a concentration and a volume that go together. Remember, we said the 3.5 liters of, there's our of, 4.25. So this goes together. Okay. You can think of it as one side of this equation is the stock solution, and one side of this is the dilute solution. But it doesn't matter. As long as you're pairing together the things that go together on the same side of the equation, it works. Okay. The other thing that's left over in this one is concentration. So what we're going to do is we're going to solve this equation for volume. Okay. Now, the reason this equation works is because if you take moles and divide it by liters and then multiply it by liters, you're going to get moles. And the moles, right? This is moles per liter. This is liters. Okay, you're going to get moles. And the moles in the dilute solution and the moles in the concentrated solution are the same number of moles. Okay, so that'll work. Okay, the other thing I want you to remember is this works with any volume unit. Just make sure you're using the same unit for both things. You can't put milliliters on one side and liters on the other side. You have to have either milliliters on both sides or liters on both sides. Okay. This one we're working in liters, but you could also do it in milliliters if you wanted to. The best rule of thumb is to don't convert a bunch of stuff if you don't have to convert a bunch of stuff. Okay, so just get your volume units to be the same and roll with it. Okay, so let's see how this is going to work. We're going to take our dilution equation. We're going to solve for V2 because we're looking for a volume. And V2 equals C1 times V1 divided by C2. Okay. C1 V1 is what goes together. That's our 3.50 liters of 4.25. When I was in school, math teachers taught us that the word of in a sentence means you have to multiply. So that's how I remember this, right? Of means multiply. So 3.5 liters of 4.25 molar, you're going to multiply those dudes. Okay. And then all of that gets divided by 11.65 molar. When we do this, the molars cancel out and we're left with this. So we multiply the top and divide it by the bottom, and look at that. We get 1.28 liters. And this is what we got using the long way. Okay. Just remember that this is only good for dilution problems and not for anything else. And if you use it in an inappropriate situation, you will get no points for it. Look, it's my hand. All right. Let's do one more example, bring this home, and then we'll be done with dilutions. All right. So here we go. Where are we at? Okay, 7.30 milliliters of 3.56 molar KBr is added to 56.2 milliliters of water. What is the concentration of diluted solution? Okay, so the first thing I want to do is look at this and say, okay, where's the things that go together? Okay, well, 7.30 milliliters of 3.56 molar KBr is great. Okay. The other thing we're paying attention to is that we have 5.26 milliliters of water. Okay. So something we need to know. This is not something we needed before, but we need it now. Let's write our dilution equation. C1V1 equals C2V2. Okay. What we need is, right, here's our ones that go together. Okay. This is our answer, so we're going to solve for this. V2 is the total volume. Okay. In previous examples, we were told what the total volume is. Here, we're told we added 7.30 and 56.2 milliliters of water. So our total volume, we have to figure that out. Okay. So the total volume is the sum of those two things, 7.30 milliliters plus 56.2 milliliters, which is 63.5 milliliters. Okay. Now that we have the total volume, we can come in here and do our solving this thing. If we're going to solve for C2, then that means C1 times V1 divided by V2. Okay. Our C1 V1 is our 7.30 milliliters of 3.56 molar, and that gets divided by 56.2 milliliters. Notice I didn't cover anything to liters because the milliliters are still going to cancel out, and so that's fine. You can do the whole thing in milliliters. When we do this, multiply the top and divide by the bottom, we're going to get 0.409 molar kBr. Okay. Should that make sense? Double check. Is this concentration we just calculated lower than the concentration we started with? Yes. So then we did a dilution. Okay. And that makes sense. All right. If you need me, I'm here. Ask questions, get help. Practice, practice, practice. We can do this. Have a good one.